So this will be a little different than what we've heard so far. I'll talk a little bit about myself, but mostly I'm trying to have a discussion about the future and about how the world is changing and how anyone listening who's planning for their future might be able to take advantage of it. And so good question, Blake. That is not a bomb. Do you know any other guesses what that might be?
Water tank.
It's kind of the opposite of that, actually.
Fire water.
Well, so the water tank was close. It's actually an air tank to go in water. It's a submarine, and it is 3D printed. A 3D printed submarine. It's just the shell, of course. You know, they're not going to 3D print the propeller, but yeah. It's
3D print.
Did I 3D print it? A place I worked at did. Yeah. So a little bit about me. I'm Daniel Elkins, Richlands High School class of 2012. Didn't do anything too exciting. I was percussion captain. This is about the most trouble I got into. So, but yeah, no. After there, I decided that I wanted to be a nuclear engineer, which I'm not, by the way. But I decided that I wanted to do that, and that led me to the University of Tennessee in Knoxville, Tennessee. I tried to see if this is still around, but there's this program called the Academic Common Market, where basically if you're interested in a 4-year degree that's not offered in your state, you can find it at a school at a bordering state and get in-state tuition. And so to study nuclear engineering, I could have gone to either Tennessee or NC State. Those are the two schools that had it for in-state tuition. So that's what I did. And I got to the University of Tennessee and I decided I loved engineering and I loved the University of Tennessee, but I didn't like nuclear engineering. And so my solution was to get the degree anyway and then do nothing with it. What I did was I immediately went into graduate school for mechanical engineering, which was what I kind of always wanted to do. And it worked out. I was able to work as a research assistant and it completely paid all my tuition and paid me a stipend for living expenses. So that's something to plan for the future if you're interested in any sort of science or research discipline. Is a lot of the time you can get it paid for if you're willing to do some research work. While I was at the University of Tennessee, the lab that I worked at was Oak Ridge National Laboratory, which is part of the Department of Energy. And so this picture here, as we were talking about, this is a 3D printed submarine. They have a facility there called the Manufacturing Demonstration Facility. And I'll talk a little more about that later. I'll show you the machine that built this thing. Yeah, what I did was I took small samples and did some boring science analysis type stuff on it and published my thesis. And then from there, I went to Virginia Tech, where I still am, doing more research. And yeah, I'm about to be finished and about to go into the industry as a business intelligence consultant with Capgemini Government Solutions, if that means anything to anyone. So yeah, let's get started today. So I want to talk to you all about how things get made and how that's going to change. And so if we focus on that word just for a second, the word, make, and just on the concept of making something, you'll quickly realize how important that is to the way we think about what we do every day and sort of how society has been formed around the way we make things to use and things that we need. In my circles, the technical term we use is manufacturing, which, if you've been on this the whole time, you heard Paul talk a lot about that. Manufacturing, you're making something systematically. And so I'm sure when many of you hear that word manufacturing, you probably think of a place that looks like this, or more currently, a place that looks like this. This is sort of what they look like now. It's cheaper than building bricks. Everything's sort of defined by cost. But yeah, these are big, slow, complicated operations, and they're very expensive. But the key principle to deal with this cost is you make a lot of something. And so that's how you get the price down. And that's how, you make a business. And so you end up parts like these. And so what is, the first thing that sticks out, anyone, Andrea, when you see this image, what's the first thing that stands out about these parts?
There's a lot of them.
There's a lot of them. And anything else?
Different shapes and
Well, are they, Okay, so in the part, they're different shapes, but between each other, are they different at all?
The tolerances are tight.
The tolerances are tight. This is probably a very good machining process that made this. I pulled this off the internet, but
You speak English, you're not engineering.
what's a what?
What the tolerances?
Oh, just like how, so you see how small those holes are?
Yeah.
Yeah, and so each of these parts have those holes located in the exact same spot, and they're all the exact same size. I'm trying to speak English here. Ideally, you want them all to be identical in the same spot, same size, but uniformly, but that's not the case. And so you want to get that variant, that the range of sizes and locations, you want that to be as tight, as small as possible. And so when you make a bunch of these, they've kind of got it down to a science. But the thing that I was wanting to point out about these is they're all identical. And that's how they're able to make all these and make money, is they're all the same shape. So you can just do them, you set up the machine to do the same thing over and over again, and you just run it. But what happens when you only need one of something and you need it to perform a very specific function, which is happening more and more? It's not so good at doing that. You can do it, but you got to have a specific machine. Someone's got to come set it up. It's very, very expensive. So let's think about the physical plant layout, like as we've seen so far, those big buildings, these. So this is a hospital. This is not a manufacturing plant. But what if we could put a factory inside the hospital? How would that change the way the hospital operates? What if you could say, if you needed a special prosthetic or a heart stent or a special tool to reach around, a bone spur to get to something? I don't know. I'm not a surgeon, but what if, in the realm of possibility, this kind of thing is becoming more and more possible each year. How would that change the way that we treat people? A place like this, right? So my dad's had a part broken on his truck for a while because I've been on back order for like months. What if the mechanic could make it with a set of instructions that come from the manufacturer, have a little corner factory in the shop that makes the part you need? So what about this? This is a armored vehicle designed for combat. What if instead of carrying people, it carried a little factory? If you had that option open to you as soldiers, someone on the battlefield, how would it change the way you plan on using whatever it is you use, whether it be drones? It could, 3D printable drones have been for years, they've been out. 3D printable guns, they had to enact laws to ban them because they work so well. What about here? If we have any hope of, I guess, setting up something there, you got to build stuff there. I mean, you're not gonna send a space shuttle up with, parts that are prefab. It's be too heavy. Wouldn't make any sense. You'd send up the raw materials and then you build them up there. So something to think about. So this on the top left, that is, anybody know what that is? Well, no, it's a large scale 3D printer. It's on the print bed, you can see those are just some black plastic parts that are being built. This is about 10 feet tall by 15 feet wide by 30 feet deep, which is much smaller than the factory I showed you. It's still very large, but much, much smaller. This is the machine that 3D printed that submarine. This is pretty close to the exact one. Another small little mini factory we have here is this is a type of 3D printer that's a robotic welding arm that you can see at the bottom. There's a robot attached to the plate that holds it. And so you can actually manufacture a 3D object using a robotic welder. These two machines together made this. This is a 3D. So this whole thing, unlike the submarine that I showed you, this whole thing is not 3D printed. But the boom arm, let's see, I don't know, can they see my, yeah, this metal boom arm was made using the wire-fed 3D printer, the robotic welder, and then this entire cabin, along with all these plastic parts, were 3D printed. So once these types of things become more available, people are going to change the way, what if you're out in some remote job with your excavator and you break the arm, or, you need to be shielded from the elements, but something happened to your cabin. If you had the capabilities, you could remotely manufacture exactly what you needed. These are small little mini factories that all 3D print metal. You can kind of see how big they are just based on, it's probably the one on the left is probably about 6 feet tall. It's 6 feet off the ground at the top. The one on the right actually can do both metal and plastic. So this, to get more into the capabilities of things, there's something very fascinating about this. This 3D prints three-dimensional cell cultures for scientific testing of tissues. And you can see by the names of these inks, bone, skin, cartilage. You can actually you can 3D print little, like, basically testing samples of these types of tissues for medicine. You can even 3D print now tumors. So you can test, the testing, they're still working the kinks out, but so the idea is that you 3D print the tumor to test, the efficacy of drugs and radiation and things like that.
Just can I ask a clarifying question?
Yeah.
So for example, the one around skin. So let's say you're a burn victim.
Yeah.
Is that 3D printer smart enough to take your molecular structure so you get a perfect match to do a skin graft over the burn?
So this,
or is that where the technology is going?
it's definitely where it's going. But so this is not my exact field of study, but I know for a fact that they have demonstrated that you can print directly onto skin. And then also, which that's not what this machine does, but that's a different machine, but you can 3D print directly onto skin. And then my understanding is that the cultures have to be grown from like a basic cell. So you could be the donor, it could be yours. Wow. So the best part about this, though, does anyone know where this was? I assume you don't, but where this was developed. This is a company called Selling, based out of Sweden, but their R&D office, Southwest Virginia, in Blacksburg, over in the CRC. Yeah, had a tour of it. It's an awesome place. This is kind of interesting. This is a machine. It's called the company is Meld. This is called friction stir welding, but you can think of it as like a giant metal crayon that you deposit the material. You can see in this layer by layer, and it made this big thing here. I don't know what this is, but speaking of tolerances again, you can see very large features and very small features, which is not easy to do in this company based in Christiansburg. So a lot of this stuff is making its way into Southwest Virginia. They have, Virginia Tech is responsible for both of these because they have a technology incubation center, and it's called the Corporate Research Center. And yeah, their clients, Cell Inc., the one that did the bioprinting, their clients are a lot of research, like hospitals and research centers. And the Meld, they do a lot of stuff for the government, Department of Defense type stuff. I'm sure that's what this is for. But yeah, pretty cool. So this has a lot of implications that aren't directly obvious, but the more you think about it, the more exciting, at least I get. The way we interact with the objects that we use to perform our daily tasks, we're so used to just having cookie cutter stuff that's all the same, and then we sort of like bend what we do around that. When it changes so that everything in our lives are customizable to fit what we need and what we want and who we are, it's going to change the way we think about things we use. And that's the future I see for this. And something else too, if you've been following the news recently, I see us going more towards localized manufacturing and away from sort of large economies of scale. You get something made thousands of miles away, have it shipped in. If you, like I said, if you have a factory that can fit inside an office, you don't have to do that. And I didn't even touch on how, which is what I spend my days thinking about. I didn't even touch on how artificial intelligence plays a role in all this. And so yeah. now anyone can, ask me any questions they might have. I like talking about anything, my background, the future.
Did you say that you were going into business intelligence versus manufacturing and stuff?
So yeah, I was telling Jordan earlier that this has been the application of my skills to this point is this, but I'm actually focused more on, I guess, the machine learning side of things now. And so I'm sure I'll come back to manufacturing at some point, but I think I will at some point, but for now I'm trying to get better at, artificial intelligence, stuff like that. So
It's a hot area.
yeah, exactly. And, companies are willing to not only hire me, but give me a free education in it. Something else, if anyone's listening about this, trying to plan for the future, there is no replacement for hands-on experience. You can read about stuff all you want, but you really don't learn until you try to use something in a way that, you think can help you. And then when you see how, you're going to make mistakes, and then iteratively you'll say, oh, well, what if I change it this way? And then that's really how you learn how to use stuff, how to learn, skills. It's the same thing. Riding a bike is the same as learning how to program. It's the same process, which is actually the number one piece of advice. I wrote this down while I was back there because I didn't want to forget it. But the number one piece of advice I would give people is, and this has helped me more than anything else, is if somebody else can figure out how to do something, so can you. People do not have superpowers. No one does. People do have skills which are learned, and some people are going to be more drawn towards certain things than others. But if you find something that you can practice at, then it doesn't bother you to practice at it, and that's probably the thing you're going to be the best at. That's, I guess, the closest thing you can get to a superpower. And so don't ever be intimidated by something that looks complicated or something you think you can't do. So, yeah. Any other questions?
So what programming language?
I use all Python because it's like I don't even know if you call me a coder because I find libraries online and
Everybody does it.
yeah. So
Cool.
yeah.
So you're talking like convolutional neural nets or
yeah, neural nets and regression. Lots of regression.
English words?
Hey, you're in banking.
Work the room.
If you don't use regression in banking, then what are you doing, man?
So as far as the manufacturing,
Yeah.
That's one area here that's hurt us
Mhm.
in the past, is there has been manufacturing here that's left,
Yeah.
Mexico, et cetera.
Yeah.
With the ability to miniaturize some of this and,
Mhm.
and do more localized manufacturing.
Yeah.
Do you see a trend of it coming back to smaller areas? Are there opportunities there for that where, people with, trade skills that can be taught and learned over at the community college, for example, can operate these machines in a manufacturing facility?
Yeah. I mean, so my understanding is the reason that manufacturers tend to leave is for cheap labor. And, a lot of the newest facilities, the kind of facilities that are going to be required to incorporate all this it's actually, they're willing to pay for more highly trained labor because they're more dependent on, they're less dependent upon economies of scale and more dependent upon specialized knowledge. And so that's the advantage that workers in the US have. And it's an advantage that workers around here could easily get. I mean, I'd say the SVCC is, or I don't know what to call it anymore, but I guess SWCC is great at identifying the needs of companies that move around here and, getting people trained. And so if someone were interested in bringing something like that to Bluestone or wherever, then I think it would catch on really well. I mean, even what they're doing up with Cell Inc. and with Meld, that's mostly R&D type work, but yeah, I think I don't see that being as much of a victim of outsourcing as like, sheet metal type stuff, traditional manufacturing. I guess if that answers your question. So. Anyone else?
Let me see. Go check Facebook. I think we're good.
All
I
right.
think we're good.